Our planet, Earth, is a dynamic and ever-changing place. We witness its power through earthquakes, volcanic eruptions, and the slow, grinding movements of tectonic plates. But what if I told you that our planet is not just changing, it's actually shrinking? Scientists have made a startling discovery. Earth's crust, the very foundation we stand upon, is collapsing under the weight of a mysterious force. This isn't a gradual process happening over millennia. This is happening now, and it's happening at a rate that has scientists baffled and concerned. The evidence is clear. Earth is losing mass, and it's losing it fast. We're not talking about a few pounds here and there. We're talking about billions of tons of Earth's mass vanishing into thin air. This revelation challenges our understanding of the planet we call home. It forces us to confront a sobering reality. The ground beneath our feet might not be as solid as we once thought, and it begs the question, what's causing this dramatic shrinking act? To truly grasp the scale of this phenomenon, let's talk about something truly massive: the Himalayas. These majestic mountains, home to Mount Everest, represent some of the most impressive geological formations on our planet. They also represent a staggering amount of mass, 10,000 billion tons to be precise. Now imagine that entire mountain range, the weight of the Himalayas with all their grandeur, simply disappearing. That's the equivalent of the mass Earth is losing due to its collapsing crust. It's a number so large it's hard to fathom or even imagine. This mass loss has profound implications. It affects everything from our planet's gravitational pull to the delicate balance of Earth's systems. It's like removing a crucial piece from a giant Jenga tower. The consequences could be catastrophic. But what is causing this massive vanishing act? What unseen hand is pulling down on Earth's crust, causing such a dramatic change? The Earth's crust, the outermost layer of our planet, is not a single solid shell. Instead, it's broken into several massive pieces called tectonic plates. These plates are constantly moving, albeit incredibly slowly, driven by the heat emanating from Earth's core. This movement is responsible for earthquakes, volcanic eruptions, and the formation of mountains. Scientists believe that the mysterious force causing Earth's crust to collapse is somehow connected to this internal heat engine. The Earth's core, a churning ball of iron and nickel, is slowly cooling over billions of years. As it cools, it releases heat, creating convection currents in the mantle, the layer beneath the crust. These currents, in turn, drive the movement of tectonic plates. However, something has changed. Scientists believe that the rate at which the core is cooling might be accelerating, leading to more vigorous convection currents in the mantle. These stronger currents could be pulling down on the Earth's crust with greater force, causing it to collapse and lose mass at an alarming rate. A world in flux. The consequences of a collapsing crust are far-reaching and potentially devastating. As Earth loses mass, its gravitational pull weakens. This could affect everything from the tides to the orbits of satellites. It could also lead to changes in sea levels, as the gravitational pull that holds the oceans in place diminishes. Moreover, the increased stress on tectonic plates caused by the collapsing crust could trigger more frequent and intense earthquakes. These earthquakes could devastate cities, trigger tsunamis, and cause widespread destruction. The increased heat flow from the Earth's core could also lead to more frequent volcanic eruptions, spewing ash and gases into the atmosphere, impacting air quality and global temperatures. In essence, a collapsing crust could throw our planet into a state of chaos, disrupting the delicate balance of Earth's systems and threatening the very foundations of human civilization. Understanding the forces at play is crucial to predicting and potentially mitigating the consequences of this global phenomenon. Inside out, while the accelerated cooling of Earth's core is a leading theory, it is not the only one being considered by scientists. Researchers are delving into a variety of potential explanations for the collapsing crust, each with its own set of intriguing possibilities. One possibility is that the movement of tectonic plates itself is contributing to the problem. The dynamic nature of these plates is a fundamental aspect of Earth's geology. As plates collide, one plate can be forced underneath the other in a process called subduction. This is a critical mechanism in the recycling of Earth's crust. This process pulls crustal material down into the mantle, effectively shrinking the Earth's surface. The material is then melted and can eventually re-emerge through volcanic activity. Another theory suggests that climate change might be playing a significant role in this phenomenon. As global temperatures rise, glaciers and ice caps melt at an alarming rate, contributing to a host of environmental changes. This melting ice adds a tremendous amount of water to the oceans, putting extra pressure on the Earth's crust. The increased water volume can lead to higher sea levels and greater stress on coastal regions. This added weight could be contributing to the collapse, particularly in areas where the crust is already thin and vulnerable. Coastal erosion and geological stress are significant factors to consider. While these theories offer possible explanations, the exact cause of the Earth's shrinking profile remains a mystery. The interplay of these factors is complex and not yet fully understood. Scientists are working tirelessly to gather more data, analyze the evidence, and unravel the complex forces at play deep within our planet. Their research is crucial in understanding the future of our ever-changing Earth. The knowledge quest, unraveling the mystery of Earth's collapsing crust, is a monumental task. This endeavor is not just a scientific challenge but a journey into the unknown, where every discovery brings us closer to understanding our planet's dynamic nature. It requires the collaboration of scientists from various disciplines, each bringing their unique expertise and perspectives to the table. From geophysicists studying the Earth's interior, who analyze rock samples and seismic data to understand the forces at play beneath our feet, to climatologists analyzing the impact of global warming, who study weather patterns and climate data to see how changes in our atmosphere affect the Earth's crust. It also requires advanced technology, the kind that allows us to peer deeper into the Earth than ever before, such as seismic sensors that can detect minute movements in the Earth's crust, providing critical data on tectonic activity, and satellites that can measure changes in Earth's gravitational field, offering a global perspective on the shifting landscape. The scientific community is rising to the challenge, celebrating breakthroughs and sharing findings at conferences. New research initiatives are being launched, with teams preparing for expeditions to gather more data from the field. International collaborations are being forged, bringing together the brightest minds from around the world to tackle this global issue, and cutting-edge technology is being deployed to gather more data and refine existing theories, pushing the boundaries of what we know. Scientists are delving deeper into Earth's interior, studying rock layers and core samples to uncover the secrets hidden beneath the surface, studying the behavior of the mantle and core with unprecedented detail, using advanced imaging technology to create detailed maps of the Earth's interior. This is not just about satisfying scientific curiosity, it's about understanding a phenomenon that has profound implications for our world. This is about understanding a phenomenon that has the potential to reshape our planet, causing dramatic changes in the landscape and triggering natural disasters, and impact the future of humanity. The knowledge we gain today will help us protect future generations and ensure a sustainable future. The more we learn about the collapsing crust, the better equipped we will be to predict its consequences and develop strategies to mitigate its impact. The better equipped we will be to predict its consequences, allowing us to create accurate risk assessments and prepare for potential scenarios and mitigate its potential impact on our civilization. By developing mitigation strategies and proposing solutions, we can work towards safeguarding our planet and its inhabitants. Our future hangs in the balance. The discovery of Earth's collapsing crust is a wake-up call. This revelation is not just a scientific curiosity, it is a stark reminder of the fragility of our planet and the urgent need for action. It reminds us that our planet is not a static, unchanging sphere but a dynamic and complex system in constant flux. The shifting tectonic plates, the erupting volcanoes, and the ever-changing landscapes are all part of a grand interconnected dance. It highlights the interconnectedness of Earth's systems, from the depths of its core to the highest peaks of its mountains. Every layer, every element plays a crucial role in maintaining the balance of our environment. This is not a time for panic but a time for action. We must channel our concern into constructive efforts, turning fear into motivation and uncertainty into determination. We must support scientific research, encourage international collaboration, and foster a global community dedicated to understanding and solving these pressing issues. Prioritizing the development of technologies that can help us understand and address this challenge is essential. From advanced monitoring systems to innovative renewable energy solutions, technology will be our ally in this fight. We must also take responsibility for our role in climate change, reducing our carbon footprint and adopting sustainable practices. Every action, no matter how small, contributes to the larger goal of preserving our planet. Working towards a more sustainable future involves everyone, from community gardens to urban sustainability projects, and educating the next generation about recycling and conservation. Every effort counts. The future of our planet, and our very existence, depends on our ability to unravel the mysteries of Earth's collapsing crust. By working together, by supporting scientific inquiry, and by fostering a culture of environmental stewardship, and by taking responsibility for our actions, we can make a significant impact. Advocacy, community involvement, and scientific research are all crucial components of this effort. We can hope to navigate this challenge and ensure a brighter future for generations to come. The passion and dedication of young people, the joy of families connecting with nature, and the relentless pursuit of knowledge by scientists all give us hope. The time to act is now. While we still have time, let us seize this moment, embrace our responsibility, and work together to safeguard the future of our planet.